Hey everyone, it's that math magician. On this video, we're going to take another look at congruency, and we're going to see, can we prove that two triangles are congruent by using a proof? Now for our example problem here, you'll notice that I do not have a flowchart ready to go. Instead, I have what we call a two-column proof. Now a two-column proof and a flowchart are essentially the same thing. It's just organizing the information a little differently. For the statement side, think of that as the information that goes in the oval of the flowchart, where the reasons are what go on the outside of those ovals. It's really just the same information, we're just presenting it in a different way. Now I have two triangles over there on the left side. They're connected by point C, and we want to decide whether or not are they congruent or are they not. So I do see right off the bat that they have some angles and sides already in common. I can see that from what's given that this angle over here at angle E is actually congruent to angle A. They're giving us that information. And then I also see that I have some sides that are equal. I see that the side length for the top triangle, EC, is congruent to the bottom side, AC. I know that by this single hash mark on each side telling me that they are congruent. So right off the bat, I have an angle and a side that's congruent. I really just need to find one more angle or one more side to prove that they're congruent. But before I do that, let's start writing into this two-column proof the information that we know. I know that the measure of angle E equals the measure of angle A. Those are the two angles that were given to us. They told us that they were equal. So the reason for this statement then is going to be given. We didn't come up with that information. That's information they told us. Now the next piece of information that I know, my next statement is going to be that they have these two sides in common. So I'm going to now say for the second statement that EC is equal to the line segment AC. Again, how do I know this information? Well, they told us that in the diagram. This information was given to us. So we're doing really good with this proof. We already have an angle, we have a side. All I have to do now is find another side or angle that's equal, and I know that they're congruent. Well, looking here, I don't see any other information with the sides. They sort of look like maybe they might be congruent. I see that this top side DE does kind of look like the same length of AB, but there's no markings on the triangle for me to know that they are congruent. So be very careful when working on a proof. Never assume that sides or angles are equal. You have to go off the information that you have. And right now, there's no way for me to know whether or not there are other sides that are congruent. The same thing can sort of be said about the angles as well. Angle D and angle B here do look like they're equal, but I don't have any information that tells me that. But when I look here at these two angles forming here at C, I sort of see an angle relationship hiding there. We see that this line segment DB intersects the line AE, and that creates these two different angles here at the point C. I see I have this angle in the bottom triangle and this angle in the top triangle. Now those are two angles formed by two intersecting lines, and they are angles that are opposite of each other. That is an angle relationship. That they are vertical angles. And that tells me that since they're vertical angles, that those two red angles are equal. I know that they're congruent because of the two intersecting lines and the opposite angles being shown. So I think we now have enough to prove that those two triangles are in fact congruent. They're going to be congruent by angle, side, angle congruency. All I have to do now is talk about these red angles in my two-column proof. Again, be very careful. We cannot say that the measure of angle C equals the measure of angle C. We can't do that because there are in fact two different angles here. We need to specify what the names are by using 3 letters instead of just a single letter. So I'm going to call the top angle here, I'll call it angle ECD. Remember, you trace the angle. I'm going to call it ECD. So I know that the measure of angle ECD equals the measure of angle for the bottom one, ACB. And how did I know that? Well, I knew that because of vertical angles. They were vertical angles, so of course then they have to be congruent. So I have my angle, my side, and my angle. This is more than enough information to show that those two triangles are in fact congruent. So we can write our conclusion statement right now. Triangle ECD is in fact congruent to triangle ACB by angle-side angle congruency. That is how we do a two-column proof. Again, it's all the same pieces that would be in our flowchart ovals, right? But now instead of using it more as a graphic organizer, we're just writing them out as a list. Same information, just a different manner of showing it. It's that Math Magician, and I'll see you on the next video.